Let LR be the language represented by regular expression R. Let LG be the language generated by a context-free grammar G. Let LM be the language accepted by a Turing machine M. Which of the following problems are undecidable? 1. Given a regular expression R and a string W, is W belonging to language of R? 2. Given a context-free grammar G, is language of G equal to null set? Given a context-free grammar G, is language of G equals to epsilon star for some alphabet epsilon? 4. Given a Turing machine M and a string W, is W belonging to language of M? Now, this is a question from theory of computation section regarding decidability and undecidability. Now, we have been given these 4 statements and we need to find out which of these problems are undecidable. Now, here I have given a few problems and whether it is decidable or undecidable for a set of languages. One is membership problem. Now, what is membership problem? Membership problem means given a string W, let us say, whether that belongs to the given grammar. That's membership problem. Now, let's say for regular grammars, if we have been given a string W, whether that belongs to a regular grammar, to check that is a decidable problem. How we do that is for every regular grammar we will have a finite automata, so we just need to run the given string in that finite automata and check whether it accepts or it rejects. So for regular grammars, membership problem is acceptable. For context-free grammars is decidable. For context-free grammars also, membership problem is decidable. How we do that is for every context-free grammar there will be push-down automata. Now we can just run the push-down automata with the string as input and check whether it accepts or rejects. Now, for recursively enumerable languages, membership problem is undecidable. The reason for that is if we input a string to a Turing machine, it can either halt or it can not halt. It can go into a loop. So in that case, if it is accepted, we can definitely say that that string is accepted by the Turing machine. But if that string is not accepted by the Turing machine, it will go into reject state or it can go into a looping state. So we can't say for sure whether a string belongs to a recursively enumerable languages just by running it on that Turing machine. So membership problem is undecidable for recursively enumerable languages. Now the second is emptiness problem. Given a grammar, we need to find out whether the language of the grammar is an empty set. So for recursive languages, this is decidable. For context-free grammar also it is decidable. How we do that is from the starting state we can keep on eliminating all the unreachable states, etc. And similarly we can find out whether there will be at least one string generated by the grammar. So the exact proof you can refer to the video lecture and find out. So the emptiness problem for regular grammar, it is decidable. For context-free grammar, it is also decidable. For recursive enumerable languages, it is undecidable. Similarly, completeness problem. Completeness problem means given an alphabet epsilon, whether the language generated by the grammar equal to epsilon star. That's what completeness problem specifies. So again, for regular grammars it is decidable, for context-free grammar it is undecidable, and for recursively enumerable languages it is undecidable. Now the proofs of all of these and similar, there are many other problems similar to this. All of that you can find out in the video lectures. There's a table given at the end of theory of computation section which outlines all such problems and decidability of the problems for regular, context-free, recursive, enumerable, and also other types of grammar such as recursive, deterministic, context-free, context-sensitive, etc. So there's a large table outlining many similar problems given at the end of theory of computation section. So please refer to that for understanding how we got this, and also the proofs of this you can see in the video lectures. So based on this information, we look at the options. Statement 1, given a regular expression R and string W, whether W belongs to L of R. That is membership problem for regular grammar. That is decidable. Given a context-free grammar G, is L of G equal to 5. Now this is nothing but the emptiness problem for context-free grammar, which is decidable as I have given here. So this is also decidable. 3, given a context-free grammar G, is L of G equal to epsilon star for some alphabet epsilon. This is completeness problem for context-free grammar. Now that is, as I have given here, completeness problem for context-free grammar is not decidable. So this is not decidable. 4, given a Turing machine M and a string W, is W belong to language of the Turing machine. Now this is membership problem. Membership problem for recursively enumerable languages is undecidable. They are just given a Turing machine M. That means a recursive enumerable language, and membership problem for that is undecidable. So 3 and 4 are undecidable here, 1 and 2 are decidable. And in the question they were asking which of the following problems were undecidable. So the answer is 3 and 4. Option D.